Hey everybody, this is Alex Merced from alexmercedcoder.com. And this is I think day 10. Day 10 of 100 days of Go and Rust. And today we're going to hit the fun topic we've all been building up to, sort of like OOP, object-oriented programming in Rust and Go. And bottom line is, like, there really isn't your traditional object-oriented programming. Your traditional object-oriented programming in most languages uses classes. And classes, you within the class you bundle properties and methods, and then you extend that through inheritance. Okay, and again, of course, the issue is like if you inherit from one class to another, you kind of inherit everything, and you only can usually, there are some exceptions, but you generally can only inherit from one class at a time. So in that case, you can't really create a whole bunch of different classes with just like pieces and then assemble the different methods you want. So it creates some level of, even though classes and inheritance can reduce the amount of redundant code, like you don't have to rewrite those methods that you inherit, it can make it where you end up having like extra methods on a thing that you don't want, or you still have to rewrite a method because you inherited from this class but the method you want is on this class, and things like that. So Rust and Go, they favor composition. So in composition, what you do is, instead of creating a bunch of different classes and you inherit from one class at a time, you create a lot of small little pieces that have maybe one or two functions, and then you compose things of the things that they are. Okay, so we saw how we can create sort of an object-like thing with like structs, and then giving those structs methods in Rust and Go. Okay, so in Go you would, first create the struct, and then you can identify the struct as a receiver of a function. In Rust, you define the struct, and then you could create an implementation block where you can define functions for that struct. Okay, so now let's talk about how to do that in Go, how to do composition in Go. It all revolves around this concept of an interface. Okay, or actually, the actual composition itself doesn't even really need interfaces, but interfaces allow that to be a little bit more possible. So first we'll actually just show like how could I do this. So let's say, let me just get rid of all this. Oh, this is Rust. Let's go to Go. Let me clean this all out. So when it comes to composition, I always like to use like the example of like a wizard. Okay. So in this case, what I may want to do is have a wizard struct. So type wizard struct. And a wizard has a name, which is a string. A wizard has an age, which is an int. Okay. And what I may want to do is also say there's different types of wizards. But in inheritance, what I would do is I would create the wizard class, and then I would create like inherit a fire wizard, a wind wizard, a lightning wizard. But the problem would come in when I want to have like a fire lightning wizard, because I wouldn't be able to inherit from fire wizard, and lightning wizard at the same time. So I'd have to choose one and then rewrite the methods of the other. Here you don't necessarily have to do that. With composition, you can do this. So type fire struct. Okay, and we'll just say that's all that is. Like, it doesn't actually have to have any properties, so it could just be an empty struct. Type wind struct. Okay, cool. And again, we'll say that there's a fire function, a fire method that the fire struct provides. Okay, so we can say type what's the word I'm looking for? Oh, func, and again f fire. It's a pretty simple, straightforward function. fmt.println fire. Okay. Oh yeah, there's no commas here. It's just the list. Okay. And then if I do the same thing for wind. Okay, so we create a method for the wind struct. Okay, and then this time we'll print wind. Now what I could do is I could create an object of each one of these structs individually. Okay, and then like a fire object would have the fire function and whatnot, and that's weird, right? What's weird? The way you have to think about creating your structs in Go is that you're not necessarily creating the full object; you're creating the pieces. Okay, building blocks. So it's a little bit different than like creating a class where you try to put everything in sort of one bundle. Because now I can do this. I can do, you know, type fire wind wizard struct, and then this struct is a wizard. And notice, this case, I'm not typing these properties. I'm not giving the property a name and a type like I did here with this struct. I'm just embedding existing structs. So, fire, wind. So when you do it this way, so you could embed another struct as a property of another struct. But when you just embed it like this, okay, then it's what's referred to as promoted. It's promoted, it's an embedded struct. So what it does, it takes all the properties of that struct and treats it as if it's property of the struct that it's embedded in. So now this fire wind wizard will have a name and an age. Okay? And it will have the fire and wind functions, because those are the properties of that's what's available to these embedded structs. But it's treated as if it's a top level. Okay, the only catch is that you can't, when you initialize it, you can't, it gets initialized a little funny. Okay. Cool. Now, in that case, I could easily make a fire wizard as well. So I could say type fire wizard struct and say, okay, this one is a wizard. So it gets the name and the age. But it's also a fire wizard. So it also has the fire. And that's going to have the fire method, the name and the age properties, but doesn't have the wind method. Okay, so a lot of times people complain, like when we get to interfaces, that like, how can I create a default version of a function? The way you do it is you create a struct that is just that method, and then you can just embed that struct in anything you want to have that method. Okay, but that's now, let's try that out. So now I can create a new fire wizard. So we'll just say Alex equals a fire wind wizard. And now here's the word that gets a little funky. Like if I want to define the fire wind wizard, okay, what I have to do is actually define the wizard piece in it. So I have to be like wizard name Alex Merced age age 36. Damn, it doesn't like that. Okay, and then it also wants me to define like fire wind. What does it not like now? Alex declare. Oh, Alex is declared but not used. Okay, but see now I don't have to do like alex.fire.fire. I can just do like alex.fire, alex.wind. So Alex, the fire wind wizard, has access to the methods that are implemented on the fire and wind struct and the properties on, and I can like fmt.println. Okay, Merced is of age this, and okay, that's going to be alex.name, alex.age. Okay. And call possible formatting directive S. Oh, I see. I need to still do printf. And I need to add the new line character, because again, we're doing a formatted string, so I need the printf function. Okay. So now let me open up the Go folder so we can see this all works. Okay. go run dot go. Fire, wind. Alex Brissett is of age 36. Okay, so basically in Go, what you do is you create all these, you implement methods on structs, but you don't have to implement it a whole bunch of structs. Okay, and now what I want to do is that maybe there's different types of wizards, right? Okay, and let's say I want there to be an interface for anyone who can use the fire spell. Okay, so like the idea is like I want to be able to create functions that say, okay, you can return something that has, as long as you return something that matches this interface. So what I can do is I can create a interface, and we'll call the interface fire W. Okay, and then in the definition of the interface, we'll sit there and say fire. Okay, and I think this is also supposed to be type fire W interface. Is that right? Yeah, there we go. Okay, and basically what the interface does, it just says it's a special type that says the things that satisfy this type is any struct that has a fire method. So in this case, usually what happens is that if I define an interface, I say, okay, hey, you have to have these functions. I might possibly have to write a version of that function for every struct I want to implement that interface. So I would have to write a version of, let's say I had 10 different structs and I want them all to be part of the fire W interface. I'd have to write a version of fire. But I can save myself the trouble by embedding the struct. So by embedding the fire struct in these two wizards, the fire struct, oh, I realized I just spelled fire totally weird. Okay, let me think about that. Fire. Oh, maybe that is right. Anyway, that's just suddenly looking funny to me. Okay, but like the fire wizard, fire wind wizard, they would all be of interface struct. So like if I do this, I want Alex to be of type fire W. Okay, let's see here. Label Alex is not used. Oh, that's right. There's no colons here. It's just like that. Okay, it would be more like var Alex fire W equals. Okay. Fire, but it does have fire. Oh, that's right. I spelled this wrong. This should be fire. Because it has to match the method name. So see, it has a fire function. And see, now it's complaining. Now, the problem here is that it doesn't like that I defined Alex with an interface that doesn't include all the methods that I plan on using. So in this case, it's like, oh, wait, you don't have all this. But let's see if it still runs. Okay, Alex.win undefined, type fire W has no field or method. So even though a fire wind wizard doesn't have it, since I said, hey, Alex has to be a type of fire W, I'm kind of explaining that, hey, I'm only intending to use these particular methods. So then it complains. So even though like the fire wind wizard struct has all these methods built in, it's still kind of complaining. Like the reason you do this, because the reason you're going to use the interface is because you're defining a function where you only plan on using these methods, these particular functions, and you just need something with these particular functions available. If I really needed everything for fire wind wizard, then I'd probably write a function where I say, hey, I need something that's a fire wind wizard, and then pass the fire wind wizard to there. So in this case, it doesn't like it because I defined this variable as the interface. Usually you would define like function arguments. So let me show you an example. Fire, so let's make this fire wind wizard. So that way it stops complaining. Okay, so if I were to write a function just to show you how we would use that interface. And again, what the interface does, it just allows you to sit there and say, hey, there's more than one struct that could be used for this function. So I could say like func cast fire. Okay, and then basically it takes one argument. It takes a wizard that must be of type fire W. So it must match that interface. Okay, and then basically what it does, it just does w.fire. Okay, and you see it doesn't, it's kind of happy with that. It's like, okay, whatever I pass in, if it doesn't throw an error, must have the fire method. So that means I'll be able to use the fire method in here safely. It's not going to be an issue, because we know that even if there's different types of structs that might get passed in here, whatever struct survives, like whatever struct doesn't throw an error, will have the fire function. That's the benefit of the interface. You can kind of sit there and say, okay, I only want this passed into this function, or I only want one of these returned from a function. So in that case, what I can do here is I can pass in, I can say like cast fire and pass in Alex. And see, it's happy. Fire, fire. Okay, and it wouldn't matter if I had passed in just a fire wizard or just a fire struct. All of those would have worked passing into that function, because it all matches the interface, and they all match the interface because either your fire, which actually implemented that function, or the other two have fire embedded in it. Okay, so the idea basically is you really would want, you're more better off creating a bunch of structs that are like one or two functions a piece, and then a separate struct that refers to, or it depends on what you need in the method. So like if the method has self-referential properties, then those properties need to be defined on the struct. But the idea is you create all those methods in for different structs, and then you can embed all those structs to create one larger struct with all these methods. And this way you're not rewriting the same method over and over again, because you're creating the smaller pieces to kind of mix and combine like a Build-A-Bear. And that's essentially composition. Okay, so that's kind of like how, so you don't inherit, you embed all these pieces. So you're going to say this one's going to have this piece, and this piece, and this piece, and this piece, by embedding smaller structs that only have maybe one or two methods. But if I embed 10 structs in another struct, that suddenly now that thing has like lots and lots of methods. And then with that, I can then use interfaces to help control what can be passed to what function in a very granular way, that allows me to have like type safety without too much redundancy in my code if you master it. So it's kind of like definitely a different way of thinking about your code, but once it clicks, which to me, like, it just clicked in the last 24 hours. Okay, I used to be always very frustrated that I had to like re-implement functions for I would write it like an interface and say, okay, this interface has these functions, and then I have to write a version of that function for every struct. Now the reason to embed structs kind of makes sense. So like that really kind of has clicked, and I can kind of see like, okay, so this is how you would do it. You would really like create a lot of smaller structs and embed them in a larger struct to create your pieces. Now Go is a little bit different in the way it handles, Rust is a little bit different in the way it handles it. So Go uses, again, you use structs, and then you can embed the structs, and then you have interfaces that kind of sit there and say, hey, this group of structs, because they all implement the same functions, can then go into this function. It's going to be kind of the same way in Rust. So except instead of an interface, it's called a trait. Okay, so a trait really represents a bundle of functions that certain structs have. Although defining sort of like default versions of the function is a little bit easier. I don't have to create a separate struct with just that function and then embed it, which is totally fine. Here what you do is you can define the trait. Okay. So we would say trait. So let me just recreate this whole wizard thing. Function exists. Okay. So we would first create the struct of wizard. Okay. Struct of wizard. Actually, even before we do that, we'll create the traits. We'll create a trait called fire. Okay. And basically in the fire trait, we can then define methods. You have to at least define the signature. So at minimum, I have to do this, like be like function fire. And this just means anything that implements that trait of fire would have to define a function called fire, which means I can then have to define it for every struct. So if I don't actually provide a full function definition here, then I got to provide it over and over. I got to do it for each struct that I plan on implementing it in, which is, again, tedious. What you can do is you can do a default version. So I could do this. I could say, okay, well, this method, what it does is just print line fire. Okay, and then I do the same thing for a trait, okay, called wind, which implements a method called wind, which prints wind. Okay, so the traits have these functions, and again, the functions don't have to be defined per se. Okay, and then we'll have another trait called wizard. Okay, which will say function, declare myself, or declare myself. But this one we will not provide a default implementation for. So we say, okay, hey, this trait has this function, but what this function does, you'll have to define per person. So now what I do is I create a struct. A struct called fire wizard. Struct fire wizard. And again, it's going to have a name, which is going to be i3 string. It's going to have an age, which is going to be i32. There's the fire wizard. So what I want the fire wizard to have is I want it to implement the fire trait. So I would say, I think it's like implement fire on. Let's go check traits. Okay, and here's something to pay attention to. If you're doing multiple things, you gotta use a semicolon. So I'm gonna go add those semicolons. But what's the thing I am looking for? The implementation. Here we go. Implement for. For is the keyword I'm looking for. So implement fire for fire wizard. I don't need to define the function because there's already a default definition, so I can just do it like that. But again, let me just make sure there's all these semicolons where I need them. Actually, if I do define a default, do I need to put a thing there? No. Okay. So I do need one here. Don't need one there. Don't need one there. Okay. And then I also want to implement wizard for fire wizard. So it's going to have those methods. The problem is declare myself hasn't been detailed. So I actually have to go now define the function in here. So function declare myself. Okay. Print line. I am a fire wizard. Okay, and then now if I want to do like the wind wizard, or let's like just do the fire wind wizard, just to kind of get to the composition point. So first we'd create the structs. Struct fire wind wizard. Okay. And then again, that's going to have a name, string, age, i32. And then once again, I can be like implement fire for fire wind wizard. Actually, when I do that, do I need a semicolon after these implement blocks? No, I don't. Okay. Implement wind for fire wind wizard. Implement wizard for fire wind wizard. But again, now I have to actually declare myself because I didn't provide a default declaration. Okay. And I should probably declare these as instance methods, which means I should pass in their self as an argument. So, and self, I'm just copy and paste that. Boop, 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 boop. Okay, so let's declare some things. So we're going to say let Alex equal a fire, wind, wizard. Okay, and then I would just do name, string. I should just do this. Alex Merced. What was it? Dot to string. Or to string. Okay, and then age 36. Okay, so that should declare the fire wind wizard semicolon. And so in that case, I should have ability to use alex.fire, alex.wind, alex.declare myself. And let's run. Let's see what fun errors Rust has for me, because, you know, it's Rust. There's going to be some errors. But it's going to give me wonderful suggestions. Again, that's why I never feel too bad about getting errors in Rust. It doesn't leave me, the compiler doesn't leave me hanging. Okay, so then in this case, I'm going to do rustc run.rs to compile the file, and then I got to run the file, so /run. Yep, okay, so let's see here. Where? Okay, so this looks like I just made a silly mistake somewhere. Yep, I forgot to finish defining this function. Okay, I am a fire and wind wizard. Okay, so let's try that again. Okay, didn't give me any errors. Didn't get the output I expected. So let's see here. Alex Merced is 36 years old. Where's that coming from? Name string. It's complaining that I never do that. String. So it's just complaining about the naming of the thing. Okay. But none of these functions ever print line, and the stuff that it did print, people exist not what I have in the code. Interesting. Am I in the wrong folder? No, I'm in the right folder. Oh, it's because I'm running the file. So first, let's just make sure that it compiles correctly. Let's see run.rs. Okay, so let's just see here. Failures are never read. So let's actually just declare myself. Let's just add, you know, like print line of years. So that would be like self.name, self.age. Okay, and a semicolon, and let me just copy the same line over to here. So that takes care of that error. Image, yep. And then declare myself should have be fine. I'll make it snake case. Okay, declare myself. Declare myself. Declare myself. Declare myself. Okay. Okay, so now we're getting some errors. So let's see here. Did I forget semicolon? Yes, I did. Okay, good. So now it did run. So let's see here. And there it goes. It works. Fire, wind. I am fire and wind wizard. Okay, so I didn't have to define the fire and wind functions for two different structs. I just had one definition. So again, by defining a default version on in the implementation in the trait block, I can save myself having to write the code over again for multiple implementation blocks. So you end up kind of in the same place. So the difference is here is instead of having to create like structs that you embed, you can do the default implementations within the trait blocks. But then the traits can then just add functions as long as they're implemented on a particular struct. So you can just type in like, if there's a default implementation, you can just be like, implement this for this struct, and now that struct has those functions. But on top of that, you can use traits for typing. So you can sit there and say this function has to be passed in something of this trait, or has to return something with this trait, as a way of kind of giving yourself some more wiggle room to use more than one different type of struct, in the same way we could use interfaces in Go. So again, composition. So the idea is you create small pieces and then you piece them together. So again, I create several traits and then I can implement them on different structs. While in Go, I can create many structs and then embed them in other structs. And then either way, I can use trait or interfaces as a way to type and create a more broader, say, hey, this category of structs can then be used as arguments or return values for these particular functions. So yeah, that's like the gist of the basics of like OOP in Rust and Go. There's always more, but I think this was a good journey into that adventure. Have a great day. I'll see you all later.